Hi students, in this lecture we are going to discuss about clinical masking involved in Peotone audiometry. We will have a brief overview on the criteria for masking, the various masking levels involved and the procedure involved in Plateau method of masking. We need to do masking whenever we suspect cross-hearing. Also, whenever the airborne gap of the test ear is greater than 10 dB, we should do masking to identify if it is a true airborne gap or it is an airborne gap induced because of cross-hearing. With respect to various masking levels, we have minimum masking level, which can be calculated by various formulas given by Lydon et al. In 1959 and Studebaker in 1964. This minimum masking level is good for suprathreshold testing, but it is highly disadvantageous for Peotone audiometry because it is time consuming, as well as at this point of time we may not have all the information to accurately calculate the minimum masking level. To overcome this, Martin in 1967 came up with the concept of initial masking level, which is equal to the air conduction threshold of the non-test ear plus 10 dB. With this amount of noise in the non-test ear, we can elevate the threshold of the bone conduction hearing in the non-test ear, thereby avoiding its participation while we are testing the test ear. While doing so, we will provide the noise through a supraoral headphones, thereby occluding the non-test ear. Whenever the ear is occluded, due to occlusion effect, the bone conduction threshold of that occluded ear will become better. To overcome this, the initial masking level should be air conduction threshold of the non-test ear plus 10 dB plus the occlusion effect in that particular frequency. Next is the maximum masking level. The amount of masking level that is sufficient enough to cause cross hearing is bone conduction threshold of the test ear plus IA. To avoid this cross hearing, the maximum masking level can be bone conduction threshold of the test ear plus IA minus 5 dB. Let us see in detail about the Plateau method of masking. It was first described by Hood in 1960. Till now, it is the standard accepted strategy to track the true threshold of the test ear. It is also known as threshold shift method. It is a psychoacoustic technique which relies on observations about the relationship between the masker level in the non-test ear and the measured threshold in the test ear. It was originally described by Hood for bone conduction masking, which is equally effective for air conduction masking as well. Hood in 1960 outlined two essential steps involved in the Plateau masking procedure. They are the demonstration of shadowing effect and identification of the changeover point. Let us look at an example to understand the Plateau method procedure. So here in this audiogram, we can see that air conduction threshold of the right ear is 0 dB and that of left ear is 40 dB. And bone conduction threshold of the right ear is 0 dB. When we measure the unmasked bone conduction threshold of the left ear, it could be equal to that of 0 dB, that is the non-test ear response due to cross hearing. To understand the masking procedure, let us look into this particular graph where the x-axis has the effective masking level in dBEM and y-axis has the hearing threshold in test ear in dBHL. The unmasked bone conduction threshold in the left ear is 0 dB, which is equal to that of the bone conduction threshold of the right ear. This has occurred due to cross hearing. To check if it is a true hearing of the left ear cochlea, we can provide initial masking level of noise in the right ear and check how it is going to affect the hearing threshold in test ear. So the initial masking level formula is the air conduction threshold of the non-test ear plus 10 dB. So at 10 dB, we are going to give a noise in the non-test ear and check how it is going to affect the threshold in the test ear. There is a shift in the threshold of test ear to 20 dB, which means it is not the true threshold of left ear. Now let us see what happens as we further increase the noise level in the non-test ear. There is equal shift in the threshold in the test ear as we increase the noise level in the non-test ear. This is called as shadowing effect. On further increase of noise, we can see till which intense level the shadowing effect can be seen. are noticed. So beyond 40 dB, the threshold in the test year is not changing. So this is the changeover point. Below the changeover point, however, we increase the intensity in the non-test year, the same amount of threshold is being shifted in the test year. So this is the shadowing region, and there is a changeover point at this particular intensity beyond which there is no change in the threshold in the test year. So till this first changeover point, whatever responses we got from the test year, they are not the responses from the test year, but they are the non-test year responses occurred due to cross-hearing. Beyond this changeover point, whatever thresholds or whatever responses we get, they are the responses from the test year. Let us see what happens if we further increase the noise in the non-test year. The trend keeps the same, but beyond a certain level, when we increase the intensity in the non-test year, again there is a shadowing effect seen. This is the second changeover point where from constant threshold in the test year, it is again shifting equal to the amount of noise increase in the non-test year. This initial changeover point is called as the minimum masking level. The minimum amount of noise required to completely avoid the participation of the non-test year. So any masking level below this minimum masking point is called as under masking, where it is not completely avoiding the participation of the non-test year, hence resulting in the non-test year responses. The second changeover point is called as the maximum masking level. So that is a maximum amount of noise that can be given to the non-test year to avoid the participation of the non-test year. Above this, when we increase the intensity in the non-test year, this noise provided in the non-test year crosses over to the test year and causes ipsilateral masking in the test year. Thereby, the shadowing effect is again seen. This is called as over masking. There is a range of intensities at which the hearing threshold in the test year is not altered, even when the intensity level in the non-test year is increased. This range is called as plateau, and the threshold in the test year during this plateau is the true threshold, where there is complete masking of the non-test year. So whatever response we get from this plateau region is the true threshold of the test year, which can be plotted in the audiogram with the masked symbol. Hope this procedure is clear and easy to understand. These are the references used for this particular lecture. Thank you.